question, you can unmute yourself if there is. Otherwise, I'll just start the webinar.
Sorry, mistake, huh?
Okay, yeah. Okay. Good morning, everyone, and welcome to another webinar which we hold as part of the regional forum of the C-SUCSeS project, which is being jointly implemented by IFPRI, IFAD, SAARC, and SDF. This project, known as the Consortium for Scaling Up Climate Smart Practices in South Asia. And this is a regional forum where we have till now had webinars and presentations from various countries, experts from various countries talking about the challenges and the opportunities, the policy constraints that they face when it comes to scaling up climate smart practices in their individual countries. And we've seen a lot of very intense and engaging discussions as well through these webinars, and I'm really grateful to everyone who participates in this series and the forum. This is our last webinar in this particular series, and therefore we actually kept this one as the last one because of the topic for the webinar, which is developing a regional cooperation strategy for scaling up climate smart agriculture in South Asia. The reason being that now that we have gone through a lot of what everyone faces, the practices that we have, we thought this would be a good way to end it. And we have Dr. Aparna Sawhney today. She's a professor with the Center for International Trade and Development in JNU. And Professor Sawhney, her research focuses on international trade, environmental policy, renewable energy, and sustainability, with an emphasis on trade environmental provisions. She has also published extensively in top international journals and authored the new face of environmental management in India. Dr. Sawhney has also served in advisory roles for the Indian government, the World Bank, and currently consults for IFPRI as well. She holds a PhD in economics from the Columbia University. So before I just move it, I'd also like to just inform everyone that this particular presentation is coming from a paper that has been authored by Dr. Sawhney as well as by Mr. Abdul Karim Sma and Mamta Pradhan, Abul Kamar, and Devesh Roy from IFPRI. With that, I would ask Dr. Sawhney to please go ahead and you can start the presentation. Thank you so much for joining us.
Thank you and good morning. Thank you so much, Anisha. So as introduced, this is a topic entitled Developing a Regional Cooperation Strategy for Scaling Up Climate Smart Agriculture in South Asia. And essentially, okay, so we will be actually reviewing the policy landscape in 6 of the South Asian countries, Bangladesh, Bhutan, India, Nepal, Pakistan, and Sri Lanka. We'll begin with the multilateral climate commitments in agriculture, as well as looking at the internal climate policies and external policies, in particular the trade policy, the trade regime that exists in these 6 countries. What becomes very relevant is, of course, the development of the regional strategy in climate adaptation, given that these 6 countries have shared ecosystems, there are spatial spillovers of these countries. We begin with the multilateral efforts for climate change mitigation and adaptation. So as is well known, the first multilateral cooperative attempt in establishing the importance of climate action began with the Intergovernmental Panel on Climate Change, the IPCC, in 1988, and much of the scientific information and the limits in terms of the temperature allowable has been set by the IPCC reports, and the successive reports have also done area studies, country focus. So it is a panel with scientists as well as social scientists. This was followed by the first multilateral cooperation treaty, which is the UNFCCC, the United Nations Framework Convention on Climate Change in 1992. One of the core principles that was followed in the UNFCCC was the common but differentiated responsibility for climate action. Given that climate change was basically coming from a stock pollutant, the greenhouse gases, and essentially countries, based on their contribution to that stock pollutant, would be having differential responsibility based on their capabilities. Then followed the Kyoto Protocol, the first multilateral treaty for mitigation. And developing countries did not have to mitigate. It was essentially the responsibility of the developed countries. All the developing countries did partake through the different programs which were in there, which was most prominently the Clean Development Mechanism. But our focus actually is going to be on the Paris Agreement of 2015, under which the developing countries, including all of the 6 countries that we are studying, have made commitments in terms of their nationally determined contributions in mitigation, and as well as submitted, barring one country, which we'll come to, the national adaptation plans for climate adaptation. Why is it that the focus has been on South Asia? Because South Asia happens to be one of the most vulnerable regions of the world, which has been impacted by climate change. As the IPCC report has established, there has been intensified desertification, heat waves, droughts, floods, extreme climate events, and this has especially affected the low-lying coastal areas and the river deltas. It is also proven that there has been decreased precipitation trend in South Asia, which has aggravated the water insecurity that we have. The ocean warming and the acidification have had negative impact on fisheries and aquaculture, which are very significant economic sectors for some of these countries. And the decline in crop yield and rise in crop diseases with climate extreme events have essentially become a major threat to food security as well as livelihoods. And what is especially disturbing is that given South Asia has had a very high incidence of poverty and undernutrition, also stunting and wasting amongst young children, climate change has only exacerbated the existing conditions of food insecurity. So the need for climate smart agriculture in South Asia is very, very high. Taking a step back, why is it that agriculture, and how much has agriculture been in the focus in the international arena? Agriculture on the whole is seen to contribute to about more than 1/5 of the global greenhouse gases. Agriculture is the largest source of the non-carbon greenhouse gases, in particular methane and nitrous oxide. And the non-OECD Asian countries account for, or have accounted for, more than 80% of the global methane emissions in rice cultivation in particular. And this 80% is essentially for the period 1990 through 2015. And while methane emissions from the livestock is also very high, the focus has been more on the rice cultivation because, and in Asia, because non-OECD Asian countries have been the largest contributor to it. Along with that, agriculture has been on focus because most of the freshwater withdrawals are made for the agricultural sector. In particular, for example, in India, almost 90% of the freshwater withdrawals are meant for agriculture. So there is acute stress from blue water withdrawal for the purpose of agriculture. These costs are often not internalized in market transactions, typically externalized, as economists call it. There is a loss in agricultural productivity, and there is an intense need for adapting to the climate changes due to the severe heat, the drought, salination, and so on and so forth. So it's well established that climate smart agriculture is essential to ensure food security, nutrition security, just a quick glimpse of the hidden costs, environmental costs, which was put forward by the FAO. In here, I will not spend much time. I'll just highlight in the table, there are two which are highlighted in color red. Of course, in India, the agricultural costs in terms of blue water withdrawal is one of the highest. This is also reflective of the fact that India happens to be the largest economy in the region, but closely followed by Pakistan, where blue water withdrawal is also very high, and there is very high level of water stress. For those of you who would be interested, please go back and see the details in the paper, but I will come back to it if you have questions. Let me just move on here. So the ecological system defies sovereign borders, and that's very typical of environmental problems, and so too in South Asia. Agricultural sector in particular has very high socio-economic significance. These 6 countries are committed to their nationally determined contributions under the Paris Agreement. But since they share the ecological systems, the riverine resources, the marine and coastal resources, the agroclimatic zones, there is a lot of regional dependency and spillovers. So the action of one impacts the action, or the impact would be felt in the neighboring regions, because environmental transactions are not evident in the market as goods and services are, but they have impact on the economic outcomes. So given these regional dependency, the cooperation is imperative to achieve also the national targets that are there, being made by the individual countries. And in particular, given the overlapping agroclimatic zones, there are a lot of commonalities in the climate-smart agricultural practices or technology that can be adopted. Just a glimpse of the economic significance of the agricultural sector for the 6 countries. Again, here I've highlighted in red. The agricultural employment as a share of total employment is very high, even in a country like India, which otherwise is considered to be one of the highest growing economies in the world today. 43% overall employment. And in particular for women, it is almost 60% of the women workforce. In Nepal also, 61% of the total employment is in agricultural sector, and 75% of the female workforce is employed in the agricultural sector. In terms of land under agriculture, we see that Bangladesh has 77% of land under agriculture. There is one figure in here which I would also like to draw your attention to, and that is in green in the last column, which shows the share of land under forest. Forest, of course, is very significant in terms of carbon sequestration. And in here, we see that Bhutan has the largest forest cover, and within its own national policies, over and over again, we will see how important forest cover is for them. And essentially also the reason for the ecological services that Bhutan is giving to the rest of the world. So in our review, because we had a lot of policies that we were scanning, the first set of policy focus is basically to identify the agri-sector commitments under the Paris Agreement of 2015, and in particular to see the specific climate-smart agricultural technologies identified within the nationally determined contributions of the 6 countries. We also looked at the national adaptation policies and also internal policies which had any specific targets being set for climate-smart agricultural practices. Next, we move on to the international trade regime, and in particular, the regime for climate-smart agricultural associated goods. We focused on seeds, we focused on agricultural machinery, as well as on renewable energy equipment. We then moved on to get a closer look at the regulatory regime in seed certification in these 6 countries and the sanitary and phytosanitary measures. And lastly, we looked at the South Asian Free Trade Agreement versus other free trade agreements of the 6 countries in order to identify why is it that the SAFTA has failed to ensure the kind of economic integration that we had expected to. And therefore, from there on, to build on what we consider would be the best way to move forward for a regional policy towards cooperation and upscaling climate-smart agricultural practices. So to begin with, when we look at the Paris agreements, the nationally determined contributions, which includes, so in this table that we are comparing, the first column essentially shows when each of these countries had joined the UNFCCC, the 1992 agreement, then the Kyoto Protocol, that's the accession that they had, and finally the Paris Agreement, the year in which they had ratified. And the last column shows their net zero commitment. As we see for Bangladesh, the net zero is yet to be actually given in terms of the year, but probably would be for 2050. For Bhutan, it actually put it as 2030, but they have already achieved it. They're already carbon neutral. India has pledged for 2070, buying time. Nepal has put it as 2050. It's under discussion in Pakistan. And Sri Lanka has also essentially pledged to 2050, but typically in the electricity generation sector. When we look at the climate-smart agricultural commitments, in particular stated in the nationally determined contributions, we see that quantitative targets were set in terms of how much they would do for, or rather against each of the identified climate-smart agriculture. For example, alternate wetting and drying, climate-resilient rice variety, or fertilizer improvement, or solar pump for irrigation, or reducing rice flooding, increasing soil organic matter. So when we look at the 6 countries, we find that Bangladesh has made the maximum number and the most impressive set of quantitative targets, identifying against each of these CSA technologies the quantitative target in terms of acreage that they want to achieve, also in number of solar pumps, for example. Next, we find it is Bhutan, followed by Nepal. India, however, has not set any quantitative targets in its nationally determined contributions to the UNFCCC under the Paris Agreement. It does have a commitment for sustainable and climate resilient agriculture. Similarly, Pakistan has also not set any quantitative targets. If we do a very broad brush of the climate smart agricultural technologies in the nationally determined contributions and the national adaptation plans, we find, yes, Bangladesh, followed by Bhutan, most extensive numerical targets, followed by Nepal and Sri Lanka. Even in the NAPS, the adaptation plan, Bangladesh is a front runner with the most extensive set of climate smart agricultural technologies, followed by Nepal, Sri Lanka, Bhutan, and Pakistan. India, although has included and has many programs in climate smart agricultural technologies, is yet to submit the national adaptation plan. It is expected it would do so in the next couple of months. Amongst the prominent climate smart agricultural technologies within the domestic policies, this is parallel to the multilateral agreements, environmental agreements, we find that agroforestry has one of the most prominent number of mentions, and therefore seems to be in the top priority, followed by drip and sprinkler irrigation, which is not surprising given the water scarcity that we have in the region, followed by climate resilient crop varieties, seeds which would be heat tolerant, salinity tolerant, drought resistant, followed by sustainable land management, particularly for Bhutan and Nepal, very prominent. We then found it was zero tillage, also strip tillage, then direct seeded rice, and also a lot of focus on renewable energy, particularly solar-powered water pumps. So now if we change gears and come to international trade and climate change, one of the first things one should note is that climate change itself threatens the traditional comparative advantages that the South Asian countries enjoy due to their natural resource base and climatic conditions in agricultural sector. So for example, India happens to be the largest producer, largest exporter of rice. And should the climatic conditions adversely affect, even that comparative advantage would essentially be threatened. So climate change has direct ramifications on trade and export earnings. And again, that makes climate smart agriculture essential and critical in South Asia, given the fragile ecosystem. There are two more things that is important as far as trade is concerned. Trade provides access to technology to abate emissions, as well as technology that would help adapt to climate change. And finally, of course, when there is a climate disaster or climate shock, it would also provide for food to countries which have suffered the climate shock. So when we look at climate regime in the South Asian countries, our first focus was on the multilateral trade regime, typically under the GATT and WTO. We find that the access to developed country markets is higher under the general system of preferences for the 6 countries, and especially for the least developed countries. However, here one should also note that 3 of the least developed countries that we are concerned with have either already graduated out of the least developed country or are expected to. So for example, Bhutan graduated out of the least developed country rank in 2023, and in 2026, Bangladesh and Nepal would also expected to graduate to the developing country status, which would mean that they would lose the concessions and the preferences that they have enjoyed under the least developed country status, which would mean they would have market erosion. They would also not enjoy the concessions in terms of cutting back on import barriers within their own countries. So that is essentially the special and differential treatment that they have been enjoying. Special and differential treatments have also been enjoyed by developing countries, but not to that extent. In agri-trade, Pakistan, Bhutan, and Nepal essentially showcase the most liberalized system in terms of import barriers, especially when we consider the trade-weighted, most favored nation applied import tariffs. South Asia, amongst the 6 countries that we are looking at, is, of course, the region is one of the least integrated regions, despite having a free trade agreement which came into effect in 2006, the SAFTA, and also several bilateral, preferential, and free trade agreements which predate 2006. As I said, the LDCs, the least developed countries, have had concessional access, greater market access in the developed countries. So we often see that the group of countries in South Asia have far more trade with external South Asian members rather than within themselves, except for two countries, Bhutan and Nepal, which are critically dependent on regional partners, and they also happen to be landlocked. And in particular, they are more dependent on India for trade, whereas the other four countries have far more trade with external trade partners. I will skip this because this is a general comparison of the MFN applied tariffs, where the only thing I would probably highlight is that Bhutan and Nepal, as I said, have one of the most liberal systems in the multilateral trade regime, although Bhutan is not a member of the WTO. What I do want to, while we are mostly talking about import tariffs, it is also important to see the column which is labeled cost to export and import. Essentially, these are costs reflective of the different permits in terms of both money cost as well as time cost, which is entailed by exporters and importers. And we see that Bhutan and Nepal have the lowest institutional costs associated with export and import, whereas one of the highest is to be found in Bangladesh, also Sri Lanka, and closely followed by Pakistan and India. We also have the next two columns, which are on logistics index. And given what we see in the previous two columns, it is not surprising that the index is the lowest for Bhutan and Nepal because they have the lowest cost associated with exports and imports. This is a table that we have built based on identification of climate smart agricultural associated technology and equipment. While there is, it is not possible to identify by HS codes the climate adaptation associated or climate mitigation associated commodities, but we can actually closely map that if we had to have climate resilient seeds, they would essentially fall under seeds for sowing, which would be, let's say, rice in the husk, or wheat seed for sowing, or maize for sowing. Similarly, when we look at precision irrigation or drip irrigation, we do not have a separate category, but it would be something that would be within agricultural, horticultural sprayers. Zero tillage seeders is, of course, already identified. So that is a straight one-on-one mapping. Similarly, solar energy associated pumps would be directly related to solar PV generators or solar PV cells or modules. Having done that, what we have in this table is comparing the 6 countries and their applied most favored nation tariff or import duty. What we have in brackets, for example, in the first row that we have, which is for rice skin husk or paddy, you see that there are 6 columns following. First is Bangladesh, then Bhutan, both with 0, which means they have 0 import duty on the import of rice seed for sowing, followed by India, which shows 80, meaning this is one of the highest import barrier tariffs that we could have. However, in brackets, we notice SF, which is the SAFTA rate, would be 0. LDC, that is the least developed country rate, would be also 0. So if the import source is one of the SAFTA countries, or if it is a LDC, it is supposed to be 0. Or if it is INP, that is the India-Nepal agreement, or the IL, which is the India-Sri Lanka agreement, under that it would be 0. Having said that, while this is the import duty, as we will see later on, India does have other non-tariff barriers, which actually make import far more restrictive. In Nepal, we find that the rate is 10% under SAFTA. This is SAFTA, which is SAPTA, the South Asian Preferential Trade Agreement, that the precursor of the SAFTA. Under SAFTA, it is 9, and under the India-Nepal, that means Nepal would charge only 5% on imports coming from India. And similarly, for Pakistan, it's 3, and Sri Lanka, it's 20. So if we actually run down the entire set, the report actually has far more details and a few more commodities. We notice that even by import duty standards, India has one of the most restrictive trade regimes. We then come to seed and food trade and associated safety and quality certifications. So when we did run through the existing regime for seed certification, we found that the countries have, all of the 6 countries do have, including India, do have limited capacity that they have reported, either in terms of their ability to implement or enforce regulations and standards. So they do have regulations and standards in place, but implementation of those policies and enforcing those policies have become difficult, either because they have administrative or technical lack administrative or technical capacity. For example, the international seed, when we think in terms of the accreditation or accredited labs for testing and certifying seeds, in Bangladesh, there is only one such accredited lab, which is actually private. There are other labs, but which are not accredited for testing and certifying seeds. India happens to have the largest number of accredited labs, which is 9, but still considering its size, 9 is a small number. Pakistan has 1, that's a government-associated lab. When we look at the border quarantine safeguards for seeds, they're pretty similar across all of the 6 countries. However, India has far more elaborate testing and approval processes. And as I had mentioned in the previous slide, when talking about the MFN tariff rates, India's import regime is quote unquote restricted as per the documents. One has to also remember that multiple ministries and departments are associated with food safety systems at different stages, beginning from the farm to processing to distribution. So at the farm level, or even at the seed level, it's typically the Ministry of Agriculture or Department of Agriculture. By the time we come to the processing, it would be the Ministry of Health, which would also have standards. And of course, distribution also would have its own standards. As the processing increases and marketing increases, there are different agencies which are involved. The other thing that we note is there is a dichotomy in terms of the food safety standards which are maintained for food which is marketed domestically for domestic consumption versus food which is destined for developed country markets, exports. And we also give examples, most recent example from India and Pakistan as well, where they have faced food consignment rejects or spice consignment rejects, as the case may be, because of the residue of toxic pesticides. And essentially where it was evident that there is very poor enforcement of safety standards, but they take the rejections pretty seriously in terms of the response that has come. However, the same kind of response doesn't seem to be there for domestic consumption. Right. Why are we getting into all of these regimes? It's because when we think in terms of climate smart agricultural technology, there are environmental provisions which would be required for CSA. We understand that climate change also exacerbates food safety standards because the changes in the climate pattern has increased the risk of incidence and virulence of pathogens. It has heightened certain pest infestations. Climate smart agriculture technology often involves biological inhibitors or synthetic inhibitors which are used to reduce greenhouse gases, for example, in terms of the animal feed, to reduce the methane which would be produced, or let's say to inhibit nitrogen, nitrous oxide emissions from fertilizers, which then lead to residues in the food or in the livestock, which then raise food safety issues. So climate smart seeds also involved sometimes genome editing. So which may not be genetically modified, but it is certainly genetically edited. So which then again raise questions of biosafety. And therefore, the environmental provisions are incredibly important for the CSA technology goods. So when we look at the SAFTA now, and the state of the environmental provisions which are built into SAFTA, we find they actually fall short of what is there even in the multilateral trading regime. And moreover, the extra-regional agreements that some of the members of the 6 countries have engaged with have far deeper environmental clauses, sometimes deeper than the WTO clauses. So a very quick comparison, if we think of the environmental provisions within SAFTA, we find that it has exception to free trade, that is departure from free trade, in order to protect human, animal, or plant life and health, which is similar to the GATT Article 2020 exception. However, it excludes conservation of exhaustible resources. It does not have the SPS chapter as the GATT does. However, the SAFTA did include assistance for improvement of national capacity in least developed countries for sanitary and phytosanitary measures, as well as technical barriers to trade. However, the last entry here is essentially, it's nothing to do with environmental provisions. That is to remind us that the SAFTA still continues trade under sensitive lists where these are not open to free trade or preferential treatment. On the other hand, when we look at these same 6 countries that they have engaged in bilateral agreements, most recent, for example, not so recent, the Japan-India comprehensive economic preferential agreement that we have, which encourages trade and dissemination of environmentally sound goods and services. It reaffirms obligations under multilateral environmental agreements to which both Japan and India are members. And this is a clause which is far deeper than what the WTO is or WTO has. So this would be considered as a WTO plus provision. When we look at Pakistan-China FTA, it contains certain environmental provisions which are compatible with the WTA. When we look at Bhutan-India agreement, India-Sri Lanka FTA, Pakistan-Sri Lanka FTA, again, it has exceptions similar to GATT Article 20B. When we look at Pakistan-Sri Lanka FTA, it has invokes the WTO SPS agreement, which of course is more than what the SAFTA does. So if we think of upscaling of climate smart agriculture in South Asia, we have to understand that there are positive externalities in sharing climate smart agricultural technologies amongst these countries with similar agroclimatic conditions. And that can only happen when there is greater economic integration, when there is coordinated environmental actions to realize the potential trade and environmental benefits, so that we can have large-scale utilization of commercially viable climate resilient seeds, for example. So greater trade and investment in the region is going to serve as a conduit for diffusion and scaling up of CSA technologies. We don't have to start from scratch because there have been already efforts, earlier efforts. We had the SAARC Action Plan on Climate Change in 2008. We had the SAARC Convention on Cooperation in Environment in 2010. We had the SAARC Seed Bank, which had essentially agreed on identifying common varieties, quality evaluation, encouraging exports and imports. Also, we think of indigenous climate resilient varieties, which would be added in the seed bank, which is going to help in getting back to traditional saline resistant or tolerant, salinity tolerant seeds. So the strategy for South Asia, as we see, is to deepen trade through an augmented SAFTA. A SAFTA which would anchor liberalization on the principle of sustainable development to build climate resilience in the region. It would have to incorporate a clear SPS clause or a chapter. It has to encourage trade in climate smart agricultural goods and services, reaffirm the multilateral climate obligations of the member states. And that is something that we can do because we are doing it with external members. And the largest economy of India needs to put its weight behind strengthening regional integration and climate adaptation, following the principles of common but differentiated responsibilities and capabilities in environment, as well as special and differential treatment in trade that we have anyway acknowledged and embraced in the multilateral forum. I will stop here. Thank you. I'll take questions.
Thank you so much, Dr. Sawhney. If there are any questions, please feel free to raise your hands, or you can also use the Q&A box to share your questions.
I don't know whether my co-authors have joined. I haven't seen.
I believe Abul is here.
I would invite Abul to add something because I know I overshot the time, but
That's okay. Abul, if you have anything to add, please join. I am just also giving you access to talk. Please feel free to join. Any questions for either of the authors or the presenter, please let us know. Okay, Dr. Sikandar, please go ahead.
Good morning.
good morning.
Thanks to Professor Saiba for very good presentation, very detailed, a lot of data, no doubt a great work you have done. I want to know that the title was related to the developing a regional cooperation strategy for scaling of climate smart agriculture. No doubt we have a lot of data of climate change, emission of greenhouse gases, business, etc., export, import. But I want to know what should we do now? Because a large number of technologies have been identified in the different SAARC countries, which are more environment friendly. We can save money, time, labor, etc. But how will scale up on large scale? Already these have been mentioned, a lot of work has been done. How will promote it on large scale? This is the issue. How many technologies, for example, I want to ask in India, farmers are automatically adopting, for example, zero tillage, bed planting, water saving. So many technologies have been already developed. A lot of data have been generated, but scaling up is a little bit slow in all countries. What are your suggestions, Dr. Saiba?
As I said during the presentation, that much has been already done. And the countries have been doing it within their own regions. In order to do it at the regional scale, we need to have far more integration in terms of economic integration, and to ensure that if there is something which is successful in one region, in a very similar agroclimatic region, it can be made readily available. So that is the reason we had said that if we make commercially viable technologies more readily available, do away with the protectionist kind of barriers that we see, of course, while still respecting the biosafety issues. For example, if Bhutan has said that we are not going to allow for genetically modified organisms, so GMO seeds are not going to be, I'm sorry about that. So if you're not going to allow GMO seeds, so we still respect that. And that is why we were scanning all of the policies which are existing in these countries. So in terms of looking at the policy landscape, how best can we upscale, respecting all of these policies which are in place? And essentially, the answer that we are looking at is to say that, well, things which are acting as a barrier, ensure that those are done away with, and identifying where is it that we have the highest barriers. And I don't know whether that answers your question, but that's essentially what our last slide was trying to get across. I also see Mamta on the
Yes.
panel.
Yeah.
So
So
would you
Dr.
like to kind of
Pradhan,
come in?
yeah, Dr. Pradhan and Dr. Roy, they're both there. So please go ahead.
Yeah, hi, Professor Aparna. As usual,
Hi.
great presentation. So there's a question from Divesh Roy, who's a senior research fellow with IFPRI. So he's with me. So he's asking, do you want to ask the question? Though you have typed it, but you can please go ahead.
I can ask, can you hear me?
Yes, I can hear you.
Yeah, I know. No, thanks for this. And this is the first time that, we have something so comprehensively done for South Asia on this. So many congratulations for that. And
Congratulations to you too. You're a co-author.
no, I mean, that would be very self-congratulatory, but that's okay. So the question is, I always think that, how much of a role, a green trade can play in this in terms of inputs, right? It requires, with climate smart agriculture, it might require. And so most of the things that we want, this is something that when we think about what was going to be done through trade in South Asia, then one big part of those trade costs are domestic costs. Even to get things to the port, to get the regulatory systems approval within the country. So that is the point that, I for scaling up climate smart agriculture in South Asia, I think trade has to play a very big role. And in that, I want to see the, what role is what I'm calling a generically a domestic trade cost. I mean, you might have a lot of tariff liberalization on the border and so on, but there are a lot of domestic trade costs in terms of regulation, in terms of getting the things to the border. And so these are I mean, I just give you an example that, if you look at if mechanization has to play a role, for instance, then, what kind of policies on, like India has such very high tariffs on agriculture equipment and machineries, right? And then if some has to be mechanization towards climate smart agriculture in some way, then that is going to be really problematic. And what you're going to have it in India will also affect Nepal, will also affect other countries and so on. So I just wanted to know that what in terms of really trade policy, including the domestic trade, has to play a role in kind of scaling up climate smart agriculture in South Asia. Maybe because of my bias, I think unless we get the trade and markets right, we probably would not be achieving the targets of scaling up CSA in the region. So I just want to see that, what all you could recommend, right, in terms of, and I know you'll say that, okay, this is the green trade, then we need to reduce tariffs and all, right? That would be very straightforward that one would look at. But, what are the kind of really levers that, we need to do and in order to get the scaling up of climate smart agriculture in South Asia,
Okay, so let me
including
get this.
domestic trade costs. Yeah.
So when you're talking about the domestic trade costs within India itself, it's also across the states and essentially the geographical space that we have across the country. So it becomes expensive, even the movement within the country. Since we have overlapping agroclimatic regions and zones with the region in terms of country borders, so for example, certain regions within West Bengal would share climatic conditions with Bangladesh, and certain seeds which are being used, let's say in the Sundarbans in Bengal, would also be applicable to the seeds in Bangladesh. So in terms of sharing, that is where it would, gravity model, your distances are actually very low there. The other thing that you were talking about in terms of the import rates are being very high and equipment and so on and so forth. So there is a small snippet that we did where we saw that a country like India, for example, is an exporter, net exporter of the seeds and some of the other preliminary materials. But the rest of the stuff that we have identified as climate smart agricultural associated goods, whether it be in renewable energy or some of the seeders, these are all being imported. So we are not net exporters. So we don't seem to be having the wherewithal to be emerging as exporters there. And that would be also true of the region as a whole. So to me, the highest scope for regional cooperation exists with the materials in terms of the seeds, and that is why I also found it very interesting that we were focusing on the seed certification aspects, the phytosanitary conditions, which are certifications and approvals which are required in there. And those could be eased. So those are not necessarily very expensive to engage in transaction. Does that answer or get anywhere close to what you were asking?
No, thank that much, but I was more of the thing, this thing is about even if we are importing, right? Now the trade takes place through global value chains, right? India is importing a lot of things, but for the regional cooperation, right? I mean, if you have policy induce so much of GVC element in edible oil, for instance. So Indonesia, Malaysia, or Argentina would export it to Nepal or to Bangladesh, and then they would be then moving to India, right? So for climate smart agriculture stuff, right? Like, even if it's being imported by India, but could this be a GVC ecosystem in the region that could be?
I think that's something that would be really interesting to get into. We have to do it in our next study.
Yeah, no, that's what I've just, I was just pitching for a paper. That's it.
Yeah.
Okay,
Thank you.
Okay. Thank you. I see. Ms. Kriti, I'm just allowing you to talk. Please go ahead. Your hand is raised.
Okay, first, this is not Miss Kriti. Okay,
Sorry.
so I'm Kriti. Okay, you can say Mr. I am Lucknow, Professor K.V. Gupta, Viti Bardhan Gupta. Thanks a lot. I really appreciate Dr. Aparna for a very nice presentation, full of information. I am a little thinking out loud here. It's really, we are talking about climate smart agriculture, and whatever study you have done, really very meaningful. Uh, but one thing that comes to my mind at this stage is, are we really at the national level or even at international level exploring the right question? Because we are deriving many new technology. Yes, they will be good for some time, and again the problem will be something else at somewhere else. So what, apart from climate smart agriculture, are we, shouldn't we also relate it to climate smart, say, consumption? Climate smart consumption, in the sense, the way we eat, and the more we eat, the wastage, of course, one aspect. Lot of it has implication on climate as well. Apart from that, the type of food, and you also talked about our comparative advantage. One of the, I mean, which is, we don't see it in economics work, but yes, as a Vishwa Guru, and we claim that, and then we also want to achieve like Viksit Bharat. But unless we mend ourselves, unless we really do something, because the example you gave in that Bhutan case, they are like quite ahead on certain terms, and they could achieve some of the targets that they had indicated. And why? Maybe because by reducing the consumption rather than more and more of production. So because as we also know, they are very good on happiness index. So I'm just thinking from that perspective, maybe thinking, linking to some spirituality aspect, when because happiness is not something to it more and more, having more and more some of the thing, but probably being more conscious about reducing our own need. And so from that perspective, I'm just thinking aloud here that maybe if we can reduce certain types of food consumption, certain type of the consumption in general, not only food, even many other things, probably we will be able to do more justice rather than only thinking about this climate smart agriculture from production perspective. Yeah.
Yeah, you're absolutely right, because consumption would essentially be then driving the production. So environmentally sustainable consumption would induce businesses to then cater to the preferences of consumers accordingly. So you're absolutely right. There is a big role for consciousness, consumer consciousness, and changing of consumption patterns. And as far as the example of Bhutan, yes, absolutely. They don't just measure welfare in terms of output. And that is why maintaining forest cover has been like a sacred goal and target for them. And essentially, they have achieved what they have, and their contribution to the rest of the world is because they have kept their forests cover intact and maintaining it with pride. Yeah, point well taken.
So next, Mr. Jahangir, if you would like to go ahead, you can unmute yourself.
Okay, good morning, everybody, and thank you very much, Aparna, for your very interesting and informative presentations. Yeah, appreciate it very much. My question is kind of not question, it's a query, like some basic query. So for climate smart agriculture, we see we need to, for like country determined data generation, we use IPCC default value. And what is your comment about updating the default value for the region, like our own estimation or using our measured data in India and this region, number one? And then number two, currently India and Bangladesh and other part of Asia, we have been using conservation agriculture, like reduced tillage, residue management, cover crop, this kind of activities. And do you have any update or any updated information about like adoption of these practices, CA practices in this region? That's it. Thank you.
Thank you for your question, but I will have to pass it on to my co-authors who have done much more work on actual field in terms of the conservation agriculture. And as far as your first question was concerned, no, I was not looking at IBCC data at all. We were scanning the different policies and the commitments. So we didn't get a chance for this study. I'd like to turn it over to Mamta to fill in on the conservation agricultural practices in India and Bangladesh, because I know you were involved in the field.
We do the survey in Nepal.
Hi, Professor Aparna. Yeah, we have Bangladesh colleagues also. So I would encourage if Dr. Apurva is there, because they are the ones who have been in the field. It would be great to hear from them.
Mamta, I can't see Dr. Chaki right now on the list.
Okay. Anybody else from the SAARC team? Because that would be...
If anyone would like to just join in from the Bangladesh team, those who are working on the field with the team, please just raise your hand and I can unmute you.
Dr. Shikandar is also there, right?
Yeah, he's there.
Yeah, he's from Pakistan, our national focal point.
Yes,
So,
yes, I am
yeah.
here.
Yeah. Could you please brief on what are the CSA technology that we had shortlisted for Pakistan, and maybe a bit elaborate on that, and then I can speak about
First,
some of the countries. Yeah, please.
First, I want to introduce myself. My name is Dr. Sikandar Khan Tanveer. Now I am working as Senior Program Specialist Crops here at SAARC Agriculture Centre. I am basically from Pakistan Agriculture Research Council, working as Principal Scientist and as a National Coordinator wheat. My PhD is in crop cultivation and farming systems. In Pakistan, 2 years before joining this here, I started when this project on climate C-SUCSeS project started. I was the first person to start the activities in Pakistan, especially in the rain-fed area. I introduced different cropping systems like soybean wheat cropping system, Sesbania wheat cropping system, and mung bean cropping system. And I also introduced different new wheat varieties which are recommended for the rain-fed areas of Pakistan to the farmers' fields, training of the farmers. Similarly, our team also promoted different climate smart technologies like DSR, mechanical transplanting of rice, alternate wetting and drying in the rice seed system of Punjab province. And they also conducted different farmer field days. And so these 6-7 technologies we introduce in the two cropping systems, that is rain-fed and as well as in the rice seed cropping system.
I'm in a meeting here.
Any other question, Dr. Sabha?
Yeah. So maybe I can add to what Dr. Shikandar has already talked about. So, as a part of this project, we had amongst a huge lot of CSA technologies that has been, in all these countries. We went through a prioritization exercise where we looked at three select. We use the World Bank Index, of course, to prioritize these CSA technologies, and we kind of zeroed down on 3 technologies on each of these countries. For example, in India, we looked at direct seeded rice, zero tillage, and resilient intercropping, actually using the seed varieties. Bhutan was more focused on sustainable land management, protected agriculture, and drip and smart irrigation technology. Pakistan, as Dr. Sikandar has already talked about, where they focused on zero tillage wheat in the rice wheat cropping system.
Zero tillage wheat and DSR rice.
Yes, and happy seed.
AWD.
Yes.
And similarly, mechanical transplanting of rice.
Yes. Yeah. So these are some of the technologies we prioritized. And for Bangladesh, we focused on bed planting with residue retention. Then there was strip tillage and zero tillage with mulch. That was what we did in Bangladesh. For Nepal, it was alternate wetting and drying and direct seeded rice and drip irrigation. For Sri Lanka, particularly, we were focused on solar-powered water pumps coupled with micro-irrigation systems. There was, of course, multi-purpose soil conservation bunds, protected agriculture for high-value crops. So these are some of the prioritized technologies that we looked at as part of this project. And what Dr. Aparna has talked about is in terms of how all these technologies, what kind of constraints in adoption and adoption at scale that kind of, matters for coming up with regional strategies. So, in some of the, I will take this opportunity to kind of talk about some of the constraints that we came across in terms of strategies for scaling up. It was, biggest issues for scaling up climate smart agriculture is actually the capital cost structure to fixed capital. Then there's this fixed to variable capital ratios, that is the whole economies of scale. Then there was this whole information and lack of credible information and knowledge that kind of inhibited the scaling up of all these CSA technologies. Of course, then the huge issue of how do you even manage risk, So the focus is on relative returns and relative risk profiles. So, the adoption does not happen in vacuum. We also looked at how, what Dr. Aparna talked about is in terms of markets and policies, which are not CSA specific, So how do this trade and domestic policies, prices, procurement kind of matter? And and as Professor Aparna talked about, like how do we kind of look back into the the whole issue of market creation, first secure the markets and then CSA based differentiation. We also looked at some of the policy offsets actually in terms of, for example, you're from India, so how the MSP procurement, that is the minimum support price procurement, kind of policies that kind of offsets the scaling up of CSA technology. So, in our experience, when we think of scaling up of these CSA technologies, generically what we find is that the market is missing. So, how do you create that? How do you expand that? It is generally, it is kind of realized, but it is or understood, but it is very, very limitedly, it is kind of not been emphasized. So these are some of the constraints and some of the policy implications that we kind of studied in depth in terms of scaling up these CSA technologies. And of course, the major inhibitors, if you ask me, for scaling up is the whole farm structures of South Asia, so they are basically smallholders. They have low access to, say, credit, insurance, information. As I talked about, the low structure of CSA, that is fixed to variable cost. As Professor Aparna talked about, the whole social and institutional networks, this is a very standard paradigm for technology adoption. Then, of course, the lack of markets and demand pull, the social economic differentiators especially, and the policy offsets, etc. So, I think these are some of the things that we kind of covered and in this project, and looked at some of the prioritized CSA technologies. So I'll stop here if there is any further questions to that.
Okay, there is one more question. I would take that one first. And there are a couple of hands also raised. So just before we go ahead, a question from Mr. Ayub Hussain. The stated 6 countries agreed to net zero in 2016-17, which is quite long before. So what are the quantitative achievements of these countries so far?
Yeah, I think Professor Aparna, this is the net zero.
So
yeah.
essentially, the net zero commitments that we showed in the table is from the most recent NDCs that were given by the countries. The earlier 2016-17 were what they were initially thinking of, but what they have committed to now in the NDCs is the latest one. These are all 2021, 2022, and so on and so forth. I think the question that you ask as to what has actually been achieved on ground is a $1 million question. While we do see in terms of, let me talk about India. India committed to bringing down the energy intensity, the emission intensity of GDP. And as far as the intensity is concerned, that is indeed reducing. But in terms of actual emissions, because climate change is driven by a stock pollutant, the actual emissions are actually increasing. So what do we have at hand? One can say that perhaps we have averted some emissions that would have happened had it been business as usual, and there have been changes due to these policies. But this doesn't really answer the way you have asked the questions. That is the reason in the NDCs, it became very important to see whether there were quantitative targets which were set. And in that quantitative targets, the only country which had said, and that was pointed out in terms of Bhutan, because of its forest cover, it has already achieved. However, it is also going to be growing, so it is yet to be seen whether the carbon sequestration which is achieved by the forest cover can more than offset the growth that is going to take place with other kind of sectors where carbon is going to be emitted. However, they're also expecting that hydropower or hydroelectricity is going to be, which is going to be increasing, will also offset carbon emissions. In terms of actual reduction, I do not know. Yeah, but maybe the next report that they submit to the UNFCCC will have those mentioned. I don't know. But yeah, that's the best that I can think of at this moment.
Okay, thank you, Dr. Sawhney. Dr. Hussain, Mr. Hussain, I hope that answers your question to an extent, at least. But the next, Dr. Raza Khan from SAARC has his hand up. Please go ahead.
Yeah, thank you, Dr. Professor Madam, for a nice presentation. I would just, it's maybe not a question, but just my observation is I'm a senior program specialist in NRM, and at the same time, I'm looking after this project from the SAARC side as a regional program coordinator. So what we observed since last December, when I looking after this, actually the government of SAARC member countries are they are like feeling that they should take out of this supporting price mechanism or the fertilizer subsidy protocols, etc. Because the excess use of fertilizer, subsidized fertilizer of particularly urea in South Asia is very big issue, and that is giving birth to this greenhouse gases. So I think we, and also in case of Bangladesh, what we observe that this, service providers, this community-based service provider sectors needs to be developed and strengthened. which can rectify the problem right at the source of where it comes. So we need in this project, I think the service provider sectors needed to be strengthened, and that should be actually that is more specifically addressing the small farmers issue. So we need to have some policies like that where we can, instead of going to industrial development, which is very high cost and input, we have to develop small workshops at the village levels where these services for machines or for fertilizer can be provided. And at the same time, what we observed in Pakistan, I think there is no that farmer is not being targeted in this activity, but there are some model farmers even in India. A lot of model farmers or which we can have to be accommodated in these climate smart agriculture, because they are very good and they are right at the middle of this problem. No, they can be it can be taken as a copy. So these farmers, they are a very good side to look after, to look for and adopt to their own level. So these are like, and I think the what already mentioned, but for the climate smart produce, whatever is produced by climate smart practices needed to be given priority in the market, because if you get a potato or whatever or wheat by climate smart practice and you get the same price with no difference of price or no difference of priority, how can a farmer go for the CSA produced technology? Because he put a lot of energy and enthusiasm in that products. So I think we need to have some take, like in developed countries, there is a take for the climate smart produce or for the products. So we may need to have a model like shops or showrooms where we can display these products and where we can tell the community that's go for this, because this is for pesticide residue free stuff. This is good for health. This is naturally produced, this and that. So I think we need to promote these technologies, not only from the input side, but from the output side. So that would be a sort of adoption. Yeah. Thank you.
Yes, thank you. Thank you. Indeed. So absolutely, the last one that you were talking about in terms of ensuring there is price premium or marketing, which is done to ensure that it has a different kind of demand and return for the farmers who are taking the CSA. I also like the fact that you were stressing the first point that you made in terms of removing inconsistent policies, that if you have fertilizer subsidies which are aggravating in terms of emissions, that should be actually removed, because we can't be having a push for CSA technology and also have aggravating policies. So yes, point well taken. Thank you so much.
Thank you.
Thank you, Dr. Sawhney. Since there are no more questions, I think we can proceed to close the session. Thank you so much, Dr. Sawhney, for joining us. And I know it must be pretty late by now. So thank you so much for staying up so late. She's actually in the US and she's joined here. So thank you for that. I also want to thank everyone who has joined these webinars the past couple of years as we work through this project. Thank you for your participation. I would also like to inform you that these webinars are being uploaded to YouTube as a playlist, and we also are tagging the presentations along with it, and we'll also share that once all of them are finished being processed. The IFPRI team is also working on a set of briefs and publications that are being developed from each of these webinars, and they will most probably be available within the next 2 weeks, and we will also share that with the audience. I hope you all enjoyed this online regional forum. And once again, thank you so much. Have a great day, everyone. And good night, Dr.
Thank you, Anisha. Thank you, Mamta. Thank you, Devesh. Thanks, everybody.
Thank you, Professor Aparna. Bye-bye.
Thank you.
Bye-bye.
Goodbye.